Alright, topic today, we are going to focus on the matrices, as you can see. But I know what matrices are the ones that we're going to be focusing on our matrices. And so the definition of matrices, matrices, a matrix. Can I define a matrix? And a matrix, it is a rectangular arrangement of digits into digits. It is a rectangular arrangement of digits into rows and then in the columns, as you can see. And to arrange my digits into what you call my rows and then in the columns. And the marongera tunita maningi, my elements are and form a rectangle, as you can see. Matrix in a bracket or corner in another bracket. You have element 3, 5, 4, minus 2, 4, and 0. So this is what we call a matrix. And if you look at the elements, they seem to form a rectangle or 3, 4, 4, 5, minus 2. So that's what we call a rectangular arrangement of digits into rows and columns. So as you can see from this, the yellow marking is short, and this is a row number 1 there. That's row number 1. And then it could show a row number 2. In other words, we're saying with the rows, as you can see, definition it passes. The definition is telling us rows are horizontal. These are the rows. So row number 1 in a 3, 4, 4. And row number 2 in a 5, minus 2, and then in the 0, as you can see. And then over what we call elements in the columns. And the elements in the columns, my elements are my columns, and the elements that are in columns and are vertical. As you can see, Tina CC represents a column. So C1 is column 1, C2 column 2, C3 is column 3. As you can see, 3 na 5, that's column number 1, 4 na minus 2, column number 2, 4 na 0. So my elements are matrix are no wrong into rows and columns. So you count the number of rows first, then you count the number of columns, page 2. So as you can see, the above matrix has got 2 rows and what? And the 3 and the 3 columns. And so therefore now, to happen up a point, the number of rows followed by the number of columns, it determines what you call the order of a matrix. And so the number of rows in the columns, it tells us the order of your matrix, and it tells us the order. So therefore, the order of a matrix is, and the one about the order, and is equals to number of rows and followed by, I think it's a number of columns, as you can see, followed by the number of columns. So that's how you would basically define it. And so for example, the above matrix setup in 2 rows and 3 columns. So I always start with the number of rows, always a number of number of columns. And an example of a matrix, 3 dot 2 dot minus 1 0, and to the order of this matrix. The order of this matrix is equals energy or row number 1, row number 2, so it's a 2. How many columns? Column number 1, column number 2, so it's a 2 by 2, and but we call it a square matrix. Why is it called a square matrix? Because the number of rows in the columns a square matrix. We call that a square matrix. Another example, the 3 5 not minus 1. And if I am to define the order of this matrix, the order of this matrix is equals to, if I count the number of rows, 1, 2, 3, 3 and by times chance about a by, and we've got 1 column. So a 3 by 1 column matrix, both in a single column. So it becomes a column matrix there. You don't get it. I got 1 and my matrix, I don't know. You know to 4 minus 2. The order of this matrix, and it's in 1 row but by 2 columns. It's a 1 row by 2 columns, so it's called a row matrix because in a 1 in a 1 row. So that's the order of a matrix. The order of matrix will go to the number of rows followed by number of columns. And we move on to what we call the position of an element in a matrix. The position now, it is determined by its position in the row and the column. And so in other words, kuti kana chida position element, tida zoti element iri papo mukati me matrix medu. Totarisa chi position row nemuchi column. Element iri mu row number 1 iri mu column number 1. For example, Given the matrix below, so matrix A, we use my capital letters to define our matrix. So matrix A, in an element X, Y, Z, 4, 2, minus 1, 3, 0, 9, and W. And so I'm going to define a form, and the chip tanga will label this is row number 1, and state this is row number 1, and this is row number 1, and row number 1 we do. So no, row number 1, this is row number 1, R1, and this is row number 2. So we've got 3 rows. And how many columns? Column number 1, is column number 2, column number 3. And so but talk about 4 are in position. 4 are in row number 2. So that's row number 2. But at the end, 4 are in column number 1 and the column number 1. That's how we define the position of the element. Consider W. W total in row number 3. That's row number 3. So at the end, column number 3. And kada define Y, as you can see, Y is in row number 1, column number 2. So it's row number 1 and column number 2. That's how you determine what you call the position of element. If you look at 0 are in row number 3, column 2. So you've got a row number 3 and column number 2. That's how you define each position of an element. So you would need these two things for you to determine the position of an element. Saka ndo concept kanasi kako. Write notes, chazopa machi, ma questions on the say, I will know it from there.